Hello everyone. In this session, we will discuss an important concept in the field of NLP, that is RAG. RAG stands for Retrieval-Augmented Generation. As indicated by its name, RAG uses two components, retrieval and generation. RAG is preferred over fine-tuning or transfer learning when real-time text generation is required. Additionally, RAG is required or useful when the context needed is not within the scope of the LLM being used. For example, if the LLM has been trained on general English data, but we want to use it for medical text, RAG can incorporate external knowledge that is not originally available within the LLM. RAG consists of three components: vector embeddings, a retriever, and a generator. Let's go over each component one by one. Vector embeddings are numerical representation of the given text data. Depending on the LLM, this numerical representation can vary in both length and values. To understand how embeddings look, consider the word Python. Its embedding will be as shown on the screen. Here, the model used is All Mini LM L6 V2 model, and it provides embeddings of the length of 384. In other models, these values might be different and the length could also vary. For example, it might be 512, it might be 600 or any other length. The next component is the retriever. In RAG, we use vector stores for retrieval. A vector store serves as a storage mechanism that stores embeddings and retrieves relevant documents. Depending on its design, a vector store can also store other details like raw text, document metadata like document ID, document page number, etc. Some well-known vector stores are FAISS, FAISS, which has been developed by Facebook, and ChromaDB. If we don't want to use a vector store, we would need to handle both storage and retrieval manually. For finding relevant documents, we could use functions like cosine similarity. Vector stores are recommended as they make retrieval and storage easy, efficient, and accurate. The last component is the LLM, which stands for Large Language Model. Its role is to generate or synthesize an answer based on the retrieved documents. Some popular LLMs include GPT, BERT, and T5. Now, let's understand the entire RAG process. Consider that we have text data related to Python, which contains information like Python's history, installation steps, OOPS concepts, PEP8 guidelines, etc. This text data will be our raw text data. In the RAG pipeline, the first task is to convert this raw text data into embeddings. As seen earlier, we can use a model to generate these embeddings. The next task is to store the embeddings so that we can refer them in the future. For this, we can use vector stores like FAISS or ChromaDB or any other vector store, which will also support or which will also function as the retriever. Now let's say a user asks the query, how do I install Python? This query will be converted into embeddings using the same model that has been used to generate the embeddings from our raw text data. Then using these embeddings, that is one from raw text data and another from the query, the vector store will find the most relevant documents related to the query, how do I install Python? These retrieved documents are then provided to the LLM, which will generate or synthesize an answer based on the provided information. That's how the entire RAG process works. For working code examples of RAG, please refer to the resources I have shared in the description box. That's it for the day. Thank you everyone for watching this video.